Welcome, in this one I'm going to walk you through the solution to this question. Does this crazy looking series here converge or not? In other words, does it converge or diverge? So this is going to go from n equals 1 to positive infinity, and it's 2 to the 2n times 3 to the 1 minus n. Not the simplest one you can begin with. So what I need to do is try to make this look like something familiar that usually often means, for example, the geometric series. So here, what I'm going to do is as follows. The 2 to the 2n I will write as 2 squared to the n, and the 1 minus n I will write as negative n plus 1 as the first step. After that, 2 to the n, that becomes 4. And from negative n and positive 1, I can factor negative 1 outside the parentheses here. And so it's going to become 4 to the n times 3 to the negative, and then n minus 1. And the summation is still from 1 to infinity there on the sigma symbol. Next, take a look. I need to make this conform to a basic rule. So for that reason, I'm going to do a clever trick. It's not really a trick, or particularly clever to be honest. Notice I have here 4 to the first times 4 to the negative first. Why am I doing that? Because 4 to the first times 4 to the negative first is really just the number 1. That's all it is. You're allowed to multiply by 1. That makes things look different, so they perhaps conform to the appearance of a particular kind of formula, but you don't actually change anything. It's a common trick in math. Multiply by a form of the number 1. So that's what this is essentially, 4 to the first times 4 to the negative first. But now what I can do is that positive 4 to the first can be factored or left this way for now, and I can take the 4 to the negative first and then multiply by the 4 to the n, which is going to give 4 to the n minus 1 times 3 to the negative 1 times n minus 1. Now what I can do is this. Observe that this is 3 to the negative first. That's the same as 1/3 in that position above my head by the meaning of negative exponents. Continue. The rest of it, as you can see at step 5, is the same as at step 4. Nothing has been changed. But then it continues as follows. You see that 4 to the first, down to step 6 is copied, the sigma symbol, and goes from 1 to positive infinity is copied. And then here, the only difference is because it's 4 to the negative, 4 to the n minus 1, and this is also to the n minus 1. You see this exponent matches that exponent, so what I can do is just rewrite this as a common fraction, 4/3 raised to the n minus 1. But now when I look at the result of step 6, what I see essentially is that I have a geometric series. It goes from 1 to infinity. This 4 is present right there, but that's 4/3. Now, you would say that the series diverges to answer the question, since r is 4/3 and 4/3 is greater than 1. That's the answer. That's it. Thanks so much. Please leave a like and subscribe. I hope it's been helpful. I'll see you in another video.